Hey everyone, this is Colt. Welcome to my Webpack YouTube mini course thing. There's a couple things I have to get out of the way first. The most important one is that there is a GitHub repo that goes along with this course. So if you follow along, if you want to see the code, I do type every line from scratch, so it is a true code along. But if you just want to check the code out at any point, use this repo, view it in the browser. There's a bunch of commits with nice detailed messages. Clone it down if you'd like to use Git, if you feel comfortable checking out each commit. And I'll reference throughout the video, I'm on commit 7 going to commit 8 and that sort of thing. Okay, the next most important thing, I know everyone's going to ask, why am I wearing a hat? I need a haircut, okay? And I thought this was better than the alternative. You see what I'm working with here? Yeah. Okay, so on to the course content. This video is about Webpack in general. So if you already know how Webpack works, what it does, what the point is, then you might want to skip this or just fast forward through it. In the next video, we start with installation. So because it is 10 videos, I did decide to spread things out instead of just rushing through everything. So I will not take offense if you speed through any videos or skip them. That's what the GitHub repo is for as well. If I were taking this course, I'd probably just start by looking at the code. I've always liked to do that before I watch any videos. Okay, so let's get going. Let's talk about what Webpack is. This is the Webpack homepage, and I like how this image explains it. Webpack can be very confusing and intimidating and cause many headaches when you're actually setting it up and configuring it, but its mission, its core goal is very straightforward. It takes a bunch of different assets, different files of different types. JavaScript, images like SVG, PNG, JPEGs, CSS, style sheets, or less, or SASS, all sorts of different files, and it combines them down, it bundles them into a smaller group of files. One file maybe, or one file for your JavaScript, one for your CSS, one for your third-party JavaScript, Vendor.js, and one for your app code, app.js. It's very configurable, which is where it can become a little tedious and pretty intimidating to people who are learning it. But the idea behind it is very simple. So in addition to just bundling things together and just shoving them into a file, it's also managing dependencies. It's making sure that code that needs to load first is loading first. So if you write a file that depends on 3 other files, those 3 need to be included first. So often it's a very complex web of dependencies and larger apps, and it would be very difficult to manage it on your own. Webpack does it for you, and it spits out 1 or 2 or however many files you tell it to bundle. And I like how the GitHub repo explains it. Webpack is a bundler for JavaScript and friends, packs many modules into a few bundled assets, and through something called loaders, which we'll talk about, modules can be CommonJS, ES6, CSS, images, JSON, CoffeeScript, blah, 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 blah. The list goes on. So we're going to see how to do a lot of this stuff. But first, I want to show you an example of an app that is already built. We'll be creating our own from scratch and configuring Webpack, but this app is substantially more complicated, way more dependencies than what we'll be doing in this course. So this is an app that I'm building for my upcoming React course. It's a color pickers website. So there's a bunch of color pickers. You can click on one, you can copy a color. There's a whole bunch of features, things like changing from hex to RGB to RGBA. All of that involves a library that helps figure out colors and convert between different color types. I'm using a library to get these nice sliders and this little snack bar thing that pops up down there. There's transitions. I'm using the React router. My point is there's a lot of different stuff going on that is third-party code that I'm depending on. There's some code to help with drag and drop. There's code for a color picker. So I can create new palettes, reorder them, I save it, and there's code in addition for this emoji picker here so I can select an emoji. Anyway, that's enough with the app itself, but it's sufficiently complicated where I think it makes sense as a good example for Webpack. So if we take a look at the code, there are, 20-something JavaScript components or React components that I've written, plus 20-something CSS files, plus a whole bunch of dependencies, lots of modules, things that I'm using like React Color, I'm using this emoji mart, I'm using Material UI, React of course, some form validator libraries. There's a lot of dependencies, and this is for a single file, and there's 20-something of them. So at the end of the day, each one of them has at least this many dependencies, and it's very tricky to determine what needs to load first. If I was manually including script tags for each one of these 20 files, it would not be sustainable. So this is built on top of Create React App, which is a pretty standard way of creating new React apps. And it uses Webpack behind the scenes in addition to some other things. But Webpack is really responsible for the bulk of the functionality behind Create React App. So it's going to take all of my JavaScript and combine it into one file. it takes all of my CSS and combines it into one file. It does a lot more, involving things like Babel, for example, but at its core, that's what it's doing. It's bundling my assets and making sure that it's managing the dependencies. So if I wanted to run the application, I can run npm start, which will run it in dev mode, which starts a local server, but it still uses Webpack. And if I open up the Chrome inspector, you can see in sources, there are, let's see, just a couple JavaScript files, bundle.js, and then main chunk.js. And this contains all of my code combined into one file. There's some weird stuff going on if you're trying to read it using eval. Basically, each one of these is a single file that I wrote, a massive string, and it's being wrapped in a Webpack module. And this is keeping track of what it exports and what it depends on. And you can actually see, for example, this is minipalette.js. Okay, that's one of the components. And if I keep scrolling over, you can see things like this. Webpack imported module 6 equals Webpack require of React. So Webpack require is how Webpack is keeping track of what is imported where, what needs to be exported, what uses what, basically manages dependencies. So it replaces my imports and exports with these Webpack requires. So if I kept going, it's pretty annoying to scroll, but you'd see, okay, Webpack require mini color box. That's another component that this component imports. It relies on that component. And what might surprise you to learn is that it's actually importing all of my CSS as well into this file. So it didn't make me a separate CSS file because I'm running in development mode. And I'll show you just a moment what it does in production. And now if I instead decide to run this in production, which I'm not really going to run it, I'm going to export, I'm going to spit out a build folder. So npm run build, this is a command with create React app. You'll see that it makes me a couple of files once it finishes. It can take a while, which is why we don't export these CSS files in development when we're constantly changing things, because it takes forever to recompile or to rebundle. Okay, so that's just finished. And if we start by going to my text editor, scrolling way up, I'll close this down here, there's now a build directory. And inside of that build, if we look at our JavaScript, there's a couple files, there's these source maps we can ignore, but they're all minified now. This is the same stuff I was looking at earlier when I was using the dev version, but now it's been all crammed together and minified, and I have separate CSS files, but if we look at them, all of my CSS separate files have been combined into one and also minified. So Webpack is doing all of this for us. Again, it's managing dependencies, it's bundling code together. And now if we look at index.html, which is somewhere in here, there's only, 2 script tags at the bottom and 1 or 2 link tags at the top, instead of 20 or 30 or 50 separate script tags that I would have to do manually. Okay, so hopefully that makes it clear what Webpack does, why you would want to use it. It's a huge headache on large apps to try and do something without Webpack or something comparable. All right, so I mentioned this in the intro video, but I want to bring it back up in case you missed it or you skipped right to this video so you could start installing stuff, which I get, by the way. But I wanted to bring it up because this repo is very important for the rest of this course, the next 9 or so videos. It includes all of the code and all of the commits that I make in all of those videos. So the link is in the description. It includes detailed commit messages. I'll talk about in each video which commit I'm currently on. So I do type everything from scratch. It is true code along, but if you want to reference the changes I'm making, or if you get lost, or you just want to look at it without the video, click on a commit and you can see the diff. You can also see the notes I've written up top. And if you're more comfortable with Git, then clone it and just check out each commit as you go. All right, so this is the initial state of our application, a very, very simple app that we're going to add Webpack into and configure it in a couple different ways. And you'll see it gets surprisingly complicated just to do a couple of the basic things. Now, that's not a dig at Webpack. It's just maybe a bit of damage control on my end, just to let you know that this stuff, it can be annoying or difficult to follow, which is why I gave you the GitHub repo so that you don't have to type everything yourself. If you want, you can follow along that way, but you can also just, check out each commit as I go, and you'll be able to see what's happening. So the code right now is the initial commit. There is no Webpack. It's a single index.html, a single app.js file, and an SVG image. So you can see, here's our HTML. There's a single script tag at the bottom. App.js has 40 something lines. Imagine that it's 4,400 lines instead of 40. and that will help make it clear why Webpack really makes your life easier once you get it set up at least. Okay, we also have some content, of course, and then I'm using Bootstrap from a CDN, so unchanged. Eventually, we'll actually be using local Bootstrap. We'll be writing some SASS to override different variables, change colors in Bootstrap, and then use Webpack to bundle it all together and make it work. But for now, it's coming straight from a Bootstrap CDN, unchanged. And this is what the app looks like when I just open the index.html. I'm warning you, it's extremely simple and not exciting. We have 2 inputs styled with Bootstrap. I can add numbers together by clicking, only adding, unfortunately, and it prints out your result down here. So some simple JavaScript and some extremely simple validation. If I put letters in here instead of numbers, I get this alert styled by Bootstrap that says, please enter 2 valid numbers. AASD is not a number, blah, 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 blah is not a number. So it's actually really horrible validation because you can cheat it as long as you have a number in that string. So this is going to be 1 plus 12, which gives me 13, even though those aren't valid numbers. But that's not really the point. The content of the code doesn't really matter much. It's more about just having JavaScript that we break up, having some SASS, having some CSS, having an image. That's what really matters. So don't get too hung up on that because the same stuff I'm going to show you will apply to more exciting, more complicated applications. But I wanted to make something simple enough to follow along with. Okay, so the first thing I'm going to do is break my code up into separate files. So that will take us into commit 2. If you're following along, that will be the second commit. So there's a couple things that I can break up from my app.js. First of all, we have these different functions. I'm going to put those in their own file, each one in its own file, in a utilities or a utils directory, because we might want to use those somewhere else in the app. Checking if inputs are valid, checking or parsing inputs, that's functionality we could use somewhere else. Also, we're just breaking it up so that we have something to bundle. It's not very fun to bundle a single file. I'm going to refactor our code to have 2 services, an alert service and a component service. And then I'm going to have a function called run that actually starts all of our code. So I'm going to do that now. I'm going to make a new folder inside of source called app. And then inside of that, another new folder called utils. And then the first utility will be parse-inputs.js. And I'm just going to cut this code right there and put it in this file. And then I'm going to do the same thing for our second utility function, which is called inputs-r-valid.js. And I'm going to cut this out and paste it in right here. There we go. And I'll fast forward through some of these changes, but I'm going to make a couple more files just so you can see the file names. In the app, I'm going to have alert.service.js. I'm going to have a component.service.js. And then I'm actually going to move my app.js into app. So I'm going to delete this when I'm done. Okay, so I'm going to fill out these files. Again, it's the second commit if you want to see how I broke the code up for yourself. Okay, so I'm back. This is the alert service. It's a class called alert service. I just moved a lot of the code into this. It relies on inputs are valid, for example. We also have component service, which doesn't have any dependencies so far. And then inside of app.js, the new app.js, I'm going to delete the old one. That's outside of my folder. Now it's just all in this app folder. So I have my utilities, 2 functions, and then I have alert service, component service, and then app.js is going to instantiate new instances of alert service and component service, call them alert service and component service, and then it has a function called run, which accepts an instance of alert service and component service, and I'm calling that at the bottom. So this is what actually starts the app. Everything else is just a function definition or a class definition, but this function run is what actually runs the code, what starts everything. So don't get too hung up on the code. It's not really the focus. All that matters is that we have code spread across different files. So now my index.html needs to change because I'm linking to the old app.js, but now it's inside of the app directory. So source/app/app.js. That should get me that file. But you probably can tell already this is going to be problematic. If I try and run it, refresh the page, there's an error. Alert service is not defined. Okay, so this is sort of a heavy-handed way of proving a point that managing dependencies is tricky. It's not so bad in this example, but we have alert service. We need to make sure that that has loaded first. We need to use component service, before we can run this code. So app.js depends on those two. But then we have alert service, which itself uses inputs are valid. So we need to make sure that it's aware of inputs are valid. Right now, all that we're actually including is a single script for app.js. We have to manually include every other file. So I'm going to do that now. I'll fast forward. Okay, so I now have all of those scripts, but once again, I need to change the order because some of them depend on one another. So app.js, I'll just put that at the bottom because it depends on everything else loading first. And now, are we good to go? Let's see. Okay, it's working. So that's a very simple example, but if we have 1,000 dependencies or 1,000 files and each one has 10 different dependencies, or something like this from the previous video, this React app that has 20-something React components, each one has a bunch of dependencies at the top. Here's a different component, a whole bunch of other dependencies. So if we're trying to manage this ourselves, it's a nightmare. Which one loads first? Instead, we use Webpack. Okay, so we're not using Webpack right now. We're doing it manually, and the point is that it sucks. So we're now going to install Webpack. So this is the end of commit 2. Right now, if you're following along, commit 3 includes installing Webpack and getting it up and running. So that is what I'm going to do right now. Okay, so to install Webpack, the first thing we need to do is actually set up our package.json. So I'm going to do an npm init. I'll do -y just to make it faster. It doesn't ask me all those questions. Now I have my package.json. And I'm going to begin by adding to my git ignore the node modules directory, just so that I'm not committing that. You don't have to do that, of course. And then in my package.json, where'd you go? I'm going to get rid of this scripts for now. We'll be adding our own script in just a moment. So we've got name, code, that's fine. I'm going to set private to be true. Again, doesn't impact anything as far as Webpack, but it just prevents it from being published on npm. Okay. Now what I'm going to do is install Webpack. So npm install -- save dev Webpack. And if I just did this, it would actually prompt me to install a second package, which is called Webpack-CLI, the command line interface. And we want that as well. We want both of them. So this sometimes takes a little bit. So I'll be back once it finishes. Okay, so that wrapped up. Now we have both of those dependencies in our package.json. Next, we're going to set up a script inside of this scripts portion, the scripts property of our package.json, and we'll go with start. So when we run npm start from the terminal, it's going to call Webpack, just like that. That's actually all we have to do for now. We'll change this. We're going to configure Webpack, but out of the box, this will work, and we can actually give it a shot right now, but we're going to run into a few problems. So before we configure Webpack, we will be configuring it and telling it all sorts of different things, that how it should work, how it should handle certain files, where it should put certain files, how many it should bundle, what it should name them, blah, 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 blah. But by default, when you install it and you don't configure anything, you don't have a configuration file, it has a couple of default values. And we can actually see one of them if I just do npm start right now. It's going to call Webpack. You can see right there. Where are you? Webpack. But if you look at the error, it's telling me it can't resolve /source. So it's actually not the most clear error, but what it's saying is it can't find index.js inside of the source directory. The default entry point that it's looking for, what it's craving, is an index.js file instead of source. And the reason it says /source instead of /index afterwards is because when you require an entire directory in Node, the index.js is what is used by default. So it's not finding it, so it's not happy. So let's make an index.js inside of our source folder. Index.js. This is where it's going to look. Let's add an alert. Hello from Webpack. We'll save. Now let's see what happens when I run npm start. Once again, by default, we didn't configure it. It's looking for that file, so we made it. Now it's also saying something about a main.js. It built our code into main.js. Okay, and then there's also a warning down here. We didn't set the mode option, so it falls back to production. We'll talk about that later in this little mini course. So if we look, there's a new folder. I did not make this folder manually. It's called dist, and there's a file called main.js. And it contains a lot of random stuff. Well, it's not random. I hate when people misuse the word random, even though I just did that. It's not at all random. It's very important Webpack magic at the top. And then you can see buried in there is our code. Now it's actually wrapped in some braces and parens and curly braces. That's because Webpack isn't just adding our code as just regular code to the end of the file. It's not just appending it down here. It's wrapping it with some Webpack magic. And in the next video, we'll actually take a look at it and understand what try and understand what it's doing. But for now, it's good enough to see that our code is in here. So it has nothing to do with the rest of our app. It has nothing to do with these component services, with the logic of that little calculator. It's not even loading right now. So let's fix that. Let's go into our index.html and at the very end include another script. This one, instead of app/app.js, it's going to be ./dist/main.js. This is the file Webpack spit out for us. This is what it just built. It's very simple. It took one file in that had a single line and it spit it out with a whole bunch of other lines. But that's all the Webpack magic I was talking about. We'll come back to it later. So now if I go back, refresh, we're getting this hello from Webpack. That alert is working. So seems to reason that if we put other code in here, it would work. And that's just what we're going to do. We're going to put our code from the app in this file. But that's actually coming up next because it's not as simple as just, copying and pasting it, because we want to keep it across the different files. So we're going to use ES6 import and export to do that for us. And then Webpack will build this one file. But the other thing we're going to do in the next video is configure Webpack, set up a basic configuration file. Right now, it's looking for index.js and it's spitting out the code in dist main.js. We didn't tell it to do that. So it's rampaging on its own. We're going to try and rein it in and tell it exactly how we want it to work. The last thing I should mention, I'm going to add the dist directory into my git ignore because just like node modules, both of these directories don't need to be included when I push this up to GitHub. They just take up space and you can derive both of them from the code. You run npm install, you get node modules. If you run npm start, Webpack will build the dist directory with the main.js. So I'm not going to include it with git. All right, so we're now at the end of the third commit if you're following along. The next commit that we'll do in the next video has to do with telling Webpack all about our app code and configuring it. So right now our app is existing in a vacuum. Webpack doesn't know about it. We have Webpack up and running, but it's only bundling this code right here. What we want to do instead is call some code in here that is from our application. And we have these 5 different application files. Inputs are valid, parse inputs, and so on. And we're going to call some code from this file. So when I bundle this file with npm start, it's going to go grab all the relevant dependencies and put them all into a file, which ideally is going to put all of these 5 files together for us. But first we have to declare which files depend on what. And the way we do that is by using ES6 imports and exports. So in each file, we're going to indicate what will be exported from this file, as well as making sure to import any relevant dependencies. For example, if we look at this one, alert service, it depends on inputs are valid. So we're going to make that clear. We're going to import inputs are valid, but we actually can't do that yet because we haven't exported anything from that file. So if we look at that, here it is, just a single function. I'm going to export inputs are valid. And then inside of my alert service, I can now import it. Import, and I didn't export default, so I need to use the exact name here instead of curly braces. Inputs are valid from, and then the path to that file from alert service is ./utils/inputs are valid. And then while I'm here, I might as well export alert service because we're using that inside of our app.js. You can see right here, I will need to import alert service. But let me just begin by exporting the other thing. So we've got component service. It doesn't have any dependencies in here, as far as I can tell. We have inputs are valid. We're done with that. We exported it. We have, what's the other one? Parse inputs. We will export that. And where are we using parse inputs? I think it's in app. You can see right here, we rely on parse inputs and inputs are valid. So I'm going to copy this line from alert service and move this into app.js at the top. And we also rely on parse inputs from ./utils/parse inputs. Okay. And then we have alert service and component service that we're using in here. But I'm going to hold off on doing that for just a moment because we have to talk about what is going in our index.js. right? This is our entry point. This is where Webpack is going to start. We need to run some code from here that will then send Webpack sniffing down through all the files to figure out the dependencies, to figure out what code needs to be bundled. So we need to have a little window into our application code. And the most logical choice would be to run this function, to call this function from inside of index. This is the function that starts everything. So instead of calling it inside of our app.js, I'm going to delete that. So I export it out of this file. So now inside of my index.js, I can import run from, and then the path to that file from index.js is not in the right spot, ./app/app is the name of the file. And then I can call run. But that's not the end of the story, because if we look at what run is using, we need to pass in an instance of the alert service and an instance of the component service. So I'm going to cut that out and move it over to index.js. But that's not enough. I can pass in alert service and I can pass in component service, but we still have to import them here. Just like in every other file where we're using something, this is a bad example. Component service, another bad example. Let's look at alert service. We need to import inputs are valid because we're using it in this file. Same thing here. If we're trying to instantiate a new alert service, we need to make it very clear we need it. This is going to tell Webpack, all right, we need to make sure alert service has loaded before we can actually create one and pass it into run. So import alert service from what are we? We're inside of index.js. So app/alert.service, and then I'll duplicate this. And this other one is component service from app/component.service. Okay, now we should be okay. We'll double check. We're importing everything we need. So importing run, alert service, and component service. Then we're calling run with the new instances of alert service and component service. App.js now just has this run function, but it also relies on inputs are valid and parse inputs. As you can see, we're using it in here. Inputs are valid, parse inputs, they have no imports, they only export a single function. And then we have component service, it doesn't import anything, but it does export. And lastly, alert service, we export it and it relies on inputs are valid. Okay, so let's see what happens now. When we actually run npm start, we now have code. We have an entry point into our application. It's not just an alert. And Webpack is going to go and I keep saying sniff. I don't know why I have that idea in my head, but it's going to burrow down and start looking in here and look at what app depends on for run. And it's going to realize, oh, this depends on inputs are valid and parse inputs. And then it's going to check those. Do they have any imports? Do they export something? And it's going to keep going and essentially form a tree for us. So let's see what happens when I run npm start. Hopefully I don't have any typos. Okay. Now let's look at what it built for us in the dist directory main.js. Now we can see all of our code is down here. Shortly, we'll address what all of this is, but all of our code is here. It's not just a single alert anymore. And we have our script included, as you can see, dist/main.js. The true test will be if we can remove all of these scripts that were there before and just have this one main.js file and have everything work still. So let's see. I'm going to refresh the page. It looks like it's working. Okay, looks good. And if we go to our sources tab, what we can see inside of our dist, there's a main.js. It's minified. It's hard to read and understand. We will talk about that, but it's working. All of our code is loading. It's being bundled into a single file. So it doesn't matter, which order we're writing these files in. We don't have to indicate, this file must load first and this one must load second. We just indicate this file depends on this and this. And then Webpack takes care of the rest. It makes sure that everything is loaded in a valid order. Okay, so I just committed the code. Again, if you're following along, everything I just did is in the 4th commit. I'll just show you the git log so far. Right here, Webpack now bundling all our code. That's what we just set up. So we still haven't configured Webpack to do anything beyond the default configuration. That's coming up next, but it's at least running all of our code. It's bundling it all together, making sure everything is in the correct order, or making sure that the dependencies are managed nicely. And then we include a single script tag and all of our code works. So this would apply instead of 4 files where we have 40 lines of code. The same idea applies where we have 100 files with 50 or 100 lines each, as long as we write explicitly what each file depends on and what it exports. Okay, next we're going to configure Webpack. We got to set up our own configuration file, and we'll dive into what's actually happening in this main.js file. I'm now working on the 5th commit in our application if you're following along with Git. And what we're going to do in this video is configure Webpack, or at least set up the config file and replicate what it's already doing, but we're going to add a couple of other settings to change the output. So we're going to begin by just talking about what it's doing for us right now. So we've already seen this. The default place it's looking for an entry point is index.js instead of source. I didn't tell it to do that. The only thing I told it to do is just run Webpack. When I run npm start, it just says, all right, Webpack, do your thing. Webpack says, oh, there's no config. I'm going to look for index.js instead of source. We didn't have it there a couple videos ago, and it gave us an error. And the other thing it's doing is it's putting the code in a directory called dist in a main.js file. I didn't say it should do that either. That's the default behavior. So if we want to change that, or in our case, if we want to add on other things, like we're going to talk about plugins and loaders throughout the rest of the course, we have to have a config file to do that. Eventually, we'll actually have one config file for development, one for production, but I'm just going to make a file. I can call this whatever I want. I'm going to call it webpack.config.js. And then there's a couple of weird things that we have to get out of the way. The syntax for these files looks like this. So we're going to export an object, and it's going to have a couple of properties. We're going to add an entry point, which I'll leave as an empty string for now. We're going to have an output, which will be an object, and we'll start with these two. So our entry point, if we're just recreating what we already have, it's /source/index.js. So not doing anything new for us, but we're explicitly telling it to do this now because it will allow us to, in addition, add some other functionality down here, which we don't have right now. Now, where do we want it to output it? Well, the first thing that we can configure is the file name, not fill name, file name. If we wanted, we can keep it as main.js. We could go with, I don't know, hello.js, just to show you that it works. And then the trickiest part is we have to tell it where to go, where to actually spit that code out. And to do it, we're going to import a module from Node that we get. We don't have to install this. It just comes with Node. It's called path. Const path equals require path. And what we do is write path.resolve, _dir name, directory name, and then the name of the folder that we want the code to go in. So in my case, I'll do dist. But to show you, you may not want to type this because you're going to make an extra directory, but just to prove my point, I'll just call this code like that. Oh, and I'm missing my equal sign up here. Okay, no wonder my editor was yelling at me. So we have file name, hello.js, path is path.resolve. So what is this all doing? What is path.resolve? Well, what this is going to do is resolve an absolute path to this code directory. So it's going to take whatever the current directory is. So if I'm running this on my machine, this path will be something like /cult, or I think I'm actually using a different account called recording user /documents wherever all my stuff is /code. But then if someone else is running it on their machine, we don't want to put this recording user hard-coded in there as the path for the output. So we can use path.resolve, which will take the current directory name, dir name, which every Node script has automatically loaded by default. Anyway, this is just a long way of saying we want to make a file called hello.js inside of a file or a directory called code. So the last step, if we want to use this configuration, is to tell Webpack to use it. So right here in our package.json, we can pass in --config and then the name of the file, webpack.config.js. Okay, so I mentioned you may not want to actually run this if you don't have this set up as dist and main.js because it's going to make you a new folder and a new file, and I'm just going to delete mine right after. But let me show you that it works. Fingers crossed that it does work. Let's see what happens. All right, we have a new folder and a file called hello.js. So that is coming from Webpack. It's not doing anything with dist anymore. We could delete that, but instead I'm going to delete my code directory. So let's do that now. rm-rf code. Okay, that file's gone. I'm going to change this back to main.js and change this to be dist. And that's what most people will do. Or you could have the folder be called build instead, but there's a lot of options. But code is probably not the best example. So the next thing we can do, just to show you why you would even do this, if we're just recreating what we already had, why go through this effort? Well, we're going to spend a lot of time adding in different plugins and loaders and having Webpack handle different types of files. But for now, remember how I said all of this is minified and ugly and hard to understand? What's happening is that it's running in production mode by default, and I can tell it, let's not do production. Let's set mode to be development. And that mode is going to tell it to stop minifying. So now if I rerun my code, or if I rerun Webpack, inside of dist, we have a main.js, and it's no longer all scrunched up into this really hard to read thing of code. Now, usually you're not going to read this anyway. That's not the point. You read your code in the files where you're writing it, but then Webpack spits out a bundle. But just to show you what it looks like, you can see all of it here. Now, one thing that's kind of annoying, I don't know if you can see this, it's using eval all over the place. This is another thing that it's being configured by Webpack automatically. If we want to change that, it's not really a performance issue, but just for understanding what's going on, we can add another thing called devtool. And if we set devtool to none, and I always forget it's a lowercase t, if I rerun it this time, again, this is not something you need to do. But if I look at the code now, you can see that all of our code is in here relatively unchanged. We don't have that weird eval stuff going on. So this allows us to actually understand what this file is doing. So the very top of it is some Webpack stuff that has to do with defining different functions to make a Webpack module. There's one called Webpack-CLI. So if we look at the code that's added in further down, for example, if we look at alert service, let's look at the file. Alert service has this class, as we've seen, and it exports that class, but it also imports inputs are valid. But let's look at what Webpack put in the file. If we go to our, I guess I closed it, our main.js, we can see that it says exports provided alert service, and it wraps the entire thing in this function to create a Webpack module, all of this right here. It ends right there. But then inside of it, we don't actually have our import anymore. I don't see that line that we had at the top of alert service that said import inputs are valid. This is gone, and it's been replaced instead with some Webpack magic where we have Webpack-CLI. See right here, Webpack-CLI source app utils inputs are valid. So Webpack is now taking control, and this Webpack-CLI is making sure that our code is all loaded in the correct order. It's managing what depends on what. So it's basically using this as a hook, seeing this here and realizing, well, it's not realizing something, but it has logic that is making sure that it's doing its own Webpack version of requiring that module. So if we keep scrolling down, we can see, for other things like app.js depends on parse inputs, so it's requiring it with Webpack-CLI, and inputs are valid, Webpack-CLI. And we can keep going, and you'll see that all of our code is in here. It's been added in and slightly modified to use Webpack-CLI to be wrapped inside of a Webpack module, and a lot of that, or all of that logic is coming from here. Okay, so I'm going to go and undo or delete the devtool none. We'll come back to that later. We'll talk about source maps, but I'm going to leave mode at development for now. So we're going to end here, actually. We haven't really configured very much. We've just seen how to recreate what we were getting already, although we did add in mode development. But in the next video, that's all going to change because we're going to start talking about loaders. How do we handle different types of files that aren't just JavaScript? So that's coming up next. We're going to have to edit our config file. So I'm going to commit right now. If you want to just see this code, it is the 5th commit. So we've seen how to take different JavaScript files and bundle them together with Webpack. It's pretty simple. It's the default behavior of Webpack. We just tell it, here's where you should start. Now just go grab all of the code that is somehow related to this index file. So go grab run and then its dependencies and so on. But that's just JavaScript. But we started out a couple of videos ago talking about how Webpack can bundle all sorts of files. Images and other static files, things like JSON, SASS, CSS, SVGs, there's a ton of stuff we can do. In this video, I'm going to show you how we actually do that. We have to install some packages, we have to modify our Webpack config, and we have to talk about loaders. So loaders are the magic, they're the key for getting Webpack to handle different types of files besides JavaScript. So they are different packages that we install, and they dictate how certain files should be pre-processed as you import them or as they are loaded. So you can transform files and do different things based off of the type of file. For example, we can handle a CSS file one way, and we can handle a SVG file another way. So on the Webpack documentation, there's a list of some of the most popular loaders. You can see under styling where it's at. There's quite a few. We'll talk about what the difference is. It seems like style loader would work for CSS, but then there's CSS loader. What do they do? How are they different? We'll also talk about getting SASS to work towards the end of this video as well. And then this is not just a complete list. There is another link that will take you to a different web page that shows you a whole bunch of other loaders that other people have written. So my point is that loaders are really, really useful. It's how we get Webpack to pre-process different types of files. So we're going to add some CSS into our application. We're going to start really simple. I'm on commit 5 working towards commit 6 if you're following along. So I'm going to make inside of my source directory a new file called main.css. So remember a couple videos ago when I showed you the large Create React app that had 30 or 20 different CSS files and they're bundled together? We could have Webpack do that for us. But we're going to start simple with a single selector. We're going to set the body background color to be purple for now. So of course, right now we're not going to see anything because we're not including this in our HTML file. We could include it as a script manually, but the idea is to go through Webpack. We could have 20 something files of CSS. Webpack should bundle them together and then somehow get it to just work. The somehow part is what we'll talk about. So we're going to need to use two different loaders. One is called style loader, one is called CSS loader. So we can begin, if we come down to styling, we're going to begin with CSS loader. And before we go any further, we have to talk about how we actually set up these loaders. This is what we add into our Webpack config file. So under module, which is an object, we're going to pass in rules, which is an array. And we can put different rules for different types of files, for different modules. So we can say, in this case, if a file ends with .css, if the name of the file, this is a regular expression. If you're not super familiar with regex, this $sign means that it has to end with .css. So it can't have CSS just in the middle of the file name. There has to be a period. We have to escape it, so that's the \period, CSS, end of string, or end of name. And then if that's the case, we will use these two loaders. So we're going to begin by installing both of them, and I'll tell you what the difference is and why you need both in just a moment. But let's do our npm install -- save dev, style loader, and CSS loader. Okay, while that's going, I'm going to go back into my Webpack config, and I'm going to update this to now have module, and then we have rules, which is an array, and then we're just going to add our first rule, where we add test. And remember, this is a regular expression, and honestly, we can just copy this one for now, just like this. Okay, and this says the file ends with .css. If that's the case, how do we want to handle it? And then we can pass in use, which is an array. And I'm going to start with just CSS loader. Okay, and I don't know why I have this extra G down there. So we're saying anytime you come across a CSS file, use CSS loader, which hopefully installed. It did. Now we have to make sure our app knows about, or Webpack knows about this main.css file. So we're going to add it. We're going to import into our index.js. So import, and we need main CSS, so /main.css. So if I do this now, Webpack will come across that CSS file, and it should match this regular expression, and it will use a CSS loader. So let's see what that does. npm start. Okay, let's go look at our main.js file. We're going to have to do some scrolling. I'm going to search for purple, and you can see down at the very bottom, we have our main.css, and it's showing up in this JavaScript file. So what's happening is that the CSS loader, it exists to take CSS and turn it into valid JavaScript code, basically turn it into really long strings and make sure it's valid JavaScript. You can see our selector here, body, background, purple, but it's not being applied right now at all. If I open up this page, if I refresh right here, there's no purple background, even though that code is included. So that's where style loader comes in. So CSS loader takes your CSS and it turns it into JavaScript. And then style loader will take that JavaScript, which is actually CSS, and inject it into the DOM. You can see right here, style loader adds CSS to the DOM by injecting a style tag. Okay, so to use it is really simple. We already installed it. We go to our Webpack config. The trickiest part is that you have to know that there is an order to this array. So we have to use them in the correct order. This one is going to translate CSS to JavaScript, and then style loader takes that JavaScript and injects it into the DOM. So we need to make sure this happens first. We have to translate the JavaScript before we can inject. So you might think we would put style loader second. They actually load in reverse order. So we need to put style loader here and then CSS loader. So when it encounters a CSS file, it's going to start with CSS loader, translate it to JavaScript, and then inject it via style loader. So let's see if it works now. I'm going to build npm start. Let's go back, check our main.js, do a search for purple. Okay, it's still here. But now, if we refresh the page, it's now purple. So how is that working? If we look at our index.html, as we've already seen, there is no link tag as far as our purple body. We only have this bootstrap CDN, but there's nothing that has to do with our CSS that we wrote. The way that it's actually getting added here is through that style loader. It's being injected. If we look in the Elements tab in the head, you can see that there has been some style added. We didn't do that. Webpack did it for us. So that is our first little taste of loaders. I know it's confusing because we're loading CSS without ever actually connecting it to a link tag in an HTML file. It's all happening through JavaScript. So if I wrote more code in main.css, or if I had a bunch of other CSS files and they were all connected, each one would be parsed and turned into JavaScript and then injected into the DOM. Now later in this course, we'll see how we can actually spit out a separate CSS file. So if you wanted to have in your dist folder, you wanted to have main.css, there are ways to do that. And we can minify it, we can do different things to the code. But for now, we've set up our first loader. So I'm going to commit right now because I'm actually going to change things to show you how we can set this up to work with SASS, SCSS files. So first I'm going to commit. I'll be right back. Okay, so we're now moving on to the next commit where we're going to incorporate SASS. So if you're not really familiar with SASS, it allows us to write, syntactically awesome style sheets. It's the original, what it stands for, SASS, but now most people use SCSS files. It doesn't really matter. But what we're going to do is write some nice SASS that will override the default Bootstrap colors, like for this button right here. We're never making that blue, it's coming from Bootstrap. To override it, we need to use SASS. So the first thing I'm going to do is actually install Bootstrap locally. So npm install -- save dev Bootstrap. So that's just going to get me the copy of Bootstrap on my machine. And then I'm going to begin by, in my index.html, removing this entirely. So we have no Bootstrap right now. We're not including it. If I refresh, we just get our purple color from that main.css. So now what I'm going to do is change my main.css a bit. I'm going to delete this, and I'm going to rename it to .scss. Now we could have actually kept CSS and SASS, and I thought about doing that to show you two separate rules, but it would be kind of weird to have CSS and SASS at the same time, because if you're already working with SASS, most people would just prefer to write SASS because it's easier. It gives you some nice features that you don't have in regular CSS. So if you want to see how the CSS works on its own, like we did earlier, you can just go back to this commit, but I'm about to change things to use SASS. Okay, so in here, what I'm going to do now is actually import Bootstrap, which is from this node modules directory. I just installed it, and the import looks like this: @import bootstrap /scss /bootstrap. Okay, so right now, we're not overwriting anything. We're just trying to get Bootstrap to work again, but using SASS this time. So if you don't know how SASS works, it's not valid CSS on its own. It has to be compiled or turned into CSS. So I can't just do this. I can't say, okay, when you find an SCSS file, any file that ends in .scss, use style loader and CSS loader, because it's not CSS. So this is going to cause a problem. But what we do is use another loader. If we go back to loaders here, under style, go back a page, there is a SASS loader. If we use less, there's a less loader. Stylus, if you like stylus. And so what these will do is in this case, take SASS and turn it into regular CSS. And then we take that CSS, turn it into JavaScript, then take that JavaScript and inject it into the DOM. So a 3-step process. Now notice that they mentioned it does rely on another package called Node.js. So we're just going to install all of them together, SASS loader and Node.js. So let's do that now. npm install -- save dev SASS loader, and then it depends on Node.js. And while that's going, I'm going to update my config file to say SCSS. I've already done that. And we need to make sure that it's now using SASS loader. Remember, the order matters. This happens first. I'm going to add some comments here actually to make this a little easier to understand. So this happens first. I'll do 1 turns SCSS or SASS into CSS. And then this, step 2, turns CSS into common JS. So it converts it to JavaScript, which is what we see in our file here, for example. Here is CSS, but it's actually valid JavaScript code. Then the last step, which is step 3, inject styles into DOM. Okay, so those are the 3 steps, and we should be good to go, assuming my install worked. Let's see what happens. So I'll save, and I need to update one thing. Forgot. We're importing main.css here. That doesn't exist anymore. Now it is a SCSS file, a SASS file. Let's see what happens when I run npm start. Moment of truth. Okay. We go to our main.js and we should see a whole bunch of stuff now. This is all the Bootstrap code that we imported. It's turned from SASS into CSS, from CSS into JavaScript, which is what we see here, and then it's injected into the DOM. If we refresh, hey, we're back to our nice Bootstrap. Now we haven't actually overridden anything, so we're going to do that next. It's really easy now. We have all this SASS set up. We can write SASS wherever we want, as long as it's an SCSS file and we're importing it somewhere. I now can override the primary color. So this is a primary button. So the way we do that is by writing, not capitalized, $primary, and then giving it a color, like teal for now. So if we'll save and we rebuild over here, go back, refresh the page, you can see that the default primary color is no longer there. We're getting our own color. And likewise, this error color right here is, I believe, danger is the name of that color. So if I want to change it, I would say @danger, or what am I doing? $danger is now going to be, let's just make it purple just to see what happens. I have to build again. Soon we'll get a dev server set up, so I don't have to keep doing this. Anytime I change something, Webpack will know about it and it will rebundle for me. And there we go, we're getting purple now. So we are successfully loading SASS through Webpack. It's sort of a convoluted, crazy idea, but it's really nice. We only have one file, but we are including this Bootstrap file too. But imagine we have 20 different files. They all get combined together. They start as SASS, they turn into CSS, then CSS to JavaScript, then JavaScript injected into the DOM. And remember, there is no CSS file. In our sources, it's all just index.html and main.js. Main.js is adding the CSS into the head right here. And you can see all of those styles. It's really long because of Bootstrap. So we will see how to get it to spit out a standalone CSS file, but we're not there yet. So I'm going to commit again. We're done with this little section. We saw our first couple of loaders. These allow us to have Webpack pre-process certain files in different ways. We write a regular expression, we install the loaders, we say which order they should run in, and we just let it do its thing. That's what loaders are there for. All right, moving on. I'm going to commit. I'll see you in the next video. So next, we're going to talk about a really important feature of Webpack, which is called cache busting. It's how we can prevent certain assets, like our main bundle.js or our CSS bundle, once we actually make a separate CSS bundle, whatever those files are, how we can prevent browsers from caching them when we don't want them to be cached. So I'm going to begin with a really quick overview of caching. So I'm on just the Webpack repo on GitHub. If I go to my network tab and I do a hard refresh, Command-Shift-R on a Mac, you'll see I'm just looking at CSS only. There are 2 CSS files, and notice their names. They are quite long and ridiculous. In addition to that, we have over here, let's see, under size, you can see the size of the file. Now I'm going to do another refresh, but a regular refresh, not a hard one. So these assets, some of them might be cached. So I'm going to refresh without shift, so no shift key. Notice that this time it says from disk cache. So what this means is that it's using the copy that it already had. My browser remembered this file. It remembered this file name and it decided, okay, we already have that. We're not going to go get the new copy because nothing has changed, or we assume nothing has changed. It's the same name. Now that's a pretty simplified explanation, but this can cause problems. If right now we're using main.js, if every time we write code and we bundle it, it's always called main.js, then it could be cached in someone's browser. And we could completely overhaul the application code and we build it again, we push it up to our server, it's running, and that person requests our website. Their browser might say, oh, I already have main.js, and just use that version. So what we can do instead is add in this crazy jumble of numbers and letters, which is called a content hash, into the file name. And what's special about that content hash is that it is actually determined. It's based off of the content in the file itself. So if nothing changes in that file, we will end up, let's just do a simplified version, ABC. So right now, my code in main.js, all of this code, we run it through this special hashing function, which is, I believe it uses one called an MD5, a very famous hashing function, and we get ABC. So next time we build, nothing has changed, we still get ABC. But then I change one character, or I delete everything and rewrite all my code, I get a completely different hash. So that time it might be this instead. Now they're much longer, they're much more complicated, but that's the idea. So every time we change our code, we get a new file name, but if we don't change the code, the file name stays the same, so that caching still works. But we're cache busting, when we change something in the code, we get a new file name. So right now it's main.js every time, that's a problem. All we have to do is add in content hash like this inside of brackets. And usually you want to do main.content hash or vendor. You don't want to just do content hash.js. And you'll see that's what they do on GitHub. If we go back to network, refresh one more time, GitHub dash blah blah blah.css frameworks dash. So they use a dash, but it's the same idea. So we're going to implement that now with content hash. And if I build right now, it's going to take the contents of this file after it builds it and before it creates the new file. But take all of this code, it hashes it using, like I said, I think it's MD5, and it gets this special hash that only corresponds to the content in here. And then it sticks that in the file name. So let's see if it works. npm start. Do we end up with content hash? What file does it make for us? Take a look. main.1eda8f blah 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 blah. And if I run it again without changing anything, it should be the same still, and it is 1eda. So remember that, 1eda. Now I'm going to change something in my code. I'm going to add a console.log to my index.js. Console.log hi. So now the code, when we build main.js, will be different, and that means that the content hash will be different, which means the name is different. So now we have fa20b15 blah blah blah. So we are getting these new file names anytime we change the code, but if we're not changing it, it stays the same. So this is really useful because if you have, like we will later on, we'll have a Vendor.js, which will contain libraries, things that aren't going to change as much. Those won't need to change. They stay the same, so we can just cache them, or the browser can cache them. But our application code might change more often, so then we get a new file name each time, which then, when it's requested from the browser, it won't be cached, or it won't use a cached version because it's a new file name it hasn't seen before. So that's all great, but we have a problem. How are we going to link? How do we include that script? Our index.html right now is including main.js. How are we going to dynamically predict, or what are we going to do? We can't just assume that it's going to be this every time because it changes. So the answer is we don't write the script ourselves. We don't include this script anymore. We're going to have Webpack build our HTML file for us and stick it in this folder. So it's going to automatically come up with the correct script name and put it at the bottom. But to do that, we have to learn about plugins. So let's do it. All right, so plugins, according to the docs, give us the option to customize the Webpack build process in a variety of ways. Very useful definition here. So Webpack comes with a bunch of these different plugins that they talk about on their webpage, but there's also a whole bunch of third-party plugins that you can find here. Awesome Webpack contains, I don't know, a couple hundred of them. So they do all sorts of things. We'll see a few more throughout the course. We'll find one, we'll use one that is going to help us minify our CSS and export CSS files. We'll see one right now, which is the HTML, where are you? HTML Webpack plugin, which will help create our HTML file for us. And we'll also see one that helps us clean up our dist folder because, spoiler, you might notice right now it's getting clogged. Every time we run start, npm start, sometimes we're getting new files. If we change our code, we get a whole new file. And if we use this Clean-webpack plugin, it will help clean it up. So plugins give us additional functionality. So let's talk about the HTML Webpack plugin. It simplifies creation of HTML files. This is especially useful for bundles that include a hash in the file name, which changes every compilation. That sounds like exactly what we need. You can either let the plugin generate a file for you or supply your own template. So we'll do both. We're going to begin by just having it make a file for us. The first thing we have to do is install it, npm install -- save dev HTML Webpack plugin. So I'm just going to copy that one, move it over here, and paste it. While that's going, let's look at how we use it. So we require it in our config file, and then there's something new we haven't seen yet. Plugins. This is something, it's a property we add to the object that we're exporting, just like entry or output. In plugins, we pass in an array that contains as many plugins as we want. So let's try it out. So let's make sure we are requiring it in our Webpack config at the top. And then we can add in plugins, which is an array. Don't forget your comma. I always do that. And then I get an error when I try and build. And then we'll just pass in new HTML Webpack plugin. So we're making a new instance of it, and we're going to save. So we haven't configured anything. Let's see what happens. I haven't told it what name I want the file to be. I haven't told it what should go in that file. All I've said is use this HTML Webpack plugin, which is going to make me some file. Let's see. Let's run npm start. Hopefully no errors, okay? Let's go back and look at our dist folder. Something changed. Index.html. It's very simple, very sparse. It has a default title. I didn't tell it to call it Webpack app. I didn't say it should be index either. We can change that if you wanted to, but I like index. It's logical. And most importantly, our script is included automatically at the bottom. So whatever this content hash is, every time, if I change it, if I change those files, we'll end up with a new script. Now we have another problem, which is our content is not in here. So even though my JavaScript is included, if I open this file right now, which for the record is not the same file I've been opening. I've been using this index where I hard-coded in main.js, but that's changed now. That doesn't exist, or main.js is not being exported anymore. So instead, I need to use this index.html. I need to open this file from my dist directory. So I'll just do it from the terminal. I'll do open dist /index, and we have a problem. There's no content on the page. Our script is here, as we saw, or as I talked about. So that part is working, but what about our HTML content? This is where we need to tell it a template to use. So this line somewhere, where is that? You can either let the plugin generate an HTML file for you, supply your own template, or use your own loader. So we're going to do the most basic template possible. We're not going to use a library. We're not going to do like handlebars or any other templating language. We're just going to do a plain HTML file. So I'm going to come over, wrong way. Here we go. I'm going to make a new file inside of my source directory, and I'll call this template.html. And I'm going to go to my original index, copy the whole thing over into template.html, but I'm going to delete things. For example, we don't need this bootstrap anymore. Webpack is going to take care of that. I don't need this script tag. Webpack takes care of that. I'm going to leave this SVG file. We're going to come back to it in a separate video to address how does Webpack work with images. But for now, this is our template. So we're going to tell this HTML plugin, use this code from this file, put the script tag at the bottom and make sure it's the correct script tag. Whatever the content hash is, it needs to match. So now all we have to do is in our Webpack config, here where we're using this plugin, we need to tell it to use that template. And we just pass in an object and a property, so template, and our template file is called template.html, whoops, and that is coming from, let's make sure we have this correct. So this is from the Webpack config file. We're inside of source, so we need to do /source/template.html. Okay, so it's going to use this template, template.html, take this code, put it into a new file, which it's calling index.html by default, and it's going to make sure to include our script tag at the bottom using the correct name, the correct file name, depending on which bundle we just built. Let's see if it works. npm start, fingers crossed. Let's look at index. Okay, so here's all of our code, all of the HTML we needed, and down at the very bottom, we have a script tag, and it's using our bundle. So every time we build now, if we change our code, we rebuild, we get a new bundle, we get a new index file with a new script tag. Let's try running it. Make sure we're using the dist/index.html. The image is not working. We'll come back to that. But our JavaScript is now loading. Our HTML is here. It looks good. Okay, so we saw a lot in this section. We talked about plugins in general. This is not the last plugin we'll see, but we actually started by talking about content hashing and cache busting. How do we set up Webpack so that it uses that content hash? It's really simple, as we saw, in the file name when it bundles. And then that enables us to bust caches. If we change something, we get a new file name. If we don't change it, it's the same file name every time. So the cached version is just fine if we don't change it. In addition, this caused a problem because we need to dynamically link to this file name. It's changing. So that's what this plugin does. We give it a template and it uses that, it builds a file for us, and this is the file we are now using. So every time that we run npm start, it makes this new file and we open this file instead of this one. We can actually delete this one entirely. I'm going to do that right now. Okay, so I'm going to commit. So if you want to follow along, I'm committing now, and I'll see you back in the next video. So far, we have one Webpack config that we're using every time we build. And that works great, but often we want to have some different functionality for development versus production. But at the same time, there's a lot of stuff that is in common between the two. So in this video, we're going to actually have 3 config files. One that is in common, that's shared between dev and production, and then one for dev and one for production. So we can add things in like a development server, a live updating server that we can just run. Instead of building the whole dist directory and having to manually open it, we can use a Webpack dev server. On the other end of things, with production, we might want to minify. We might want to export our CSS into a separate file. So we're going to basically set up the framework for us to do that in this video. Just to show you what we're aiming for, this is that React app I showed you very early on. If I run npm start, it's not actually building a new directory. It's not making a dist or a build directory. Instead, it's opening up a live server. You can see localhost 3000. My app is working. And if I change something, it updates automatically. Now, if we go back and I instead run npm run build, this is going to use production mode for Webpack. And you'll see that we don't get a live server. It takes longer. Things are being optimized and minimized. And we end up with an exported directory. It's not exported, but we end up with a new directory called build once it finishes. So if I do an ls, you can see now there's a directory called build, cd build, and there's a couple of files, no live server, but things are compressed, they're minified, and they're ready for production. So we're going to go for the same sort of idea. We're going to have npm start up a dev server in our little mini app, and then npm run build will actually run it in production and create the dist directory. But first, we are going to make a couple of config files. So we have webpack.config. I'm going to make another file called webpack.dev.js and one more, which will be webpack. Let's do prod.js. And I'm going to begin by just copying what we already have into both of them, and then we can selectively delete things. So for example, in production, we want mode to be production. And entry point we can get rid of because we'll keep that in the common one. which I'll rename this to be common, webpack.common.js. These names are up to us. We're going to pass them in when we actually run Webpack from our package.json script. So webpack.common, I'm going to keep entry point. I'm going to get rid of mode. I'm going to get rid of output because in my dev version, I don't want the content hash. In my production version, I do. It's easier in dev to just not deal with the hashing, just have, main.js. It's not a big deal, but we can at least set up some differences so you can see it's working. So we can get rid of entry, but we'll do main.js. Over here, we'll do main.contenthash.js in production. What else? We can get rid of the plugins for now from dev and from prod. Those will be the same, but we'll keep it in common. We can keep the SCSS loading. Eventually, we'll be minifying our SASS and our CSS in production and not in development. So this will leave the common file, but for now, it can stay here. So this is the stuff that we have in common between the two. And then in dev, I'm going to get rid of all of these rules here and just keep it like this, mode development, production, same thing. So we'll be updating this as we go. But right now, this isn't going to work. Well, it could work, but we're not going to merge them with common. So if I want dev to also include the functionality from common, and I want production to include the same functionality from common, I'm going to use a package called Webpack-merge. So npm install -- save dev webpack-merge. And this allows us to very easily merge Webpack config together. So that finished. And I'm going to start by exporting. Actually, I don't need to do that. It's already module.exports from webpack.common.js. Now I'm going to require it here. So we'll call it common equals require. And then the path is /webpack.common. So that gives us the contents of this file of common. And then I'm going to import merge. Const merge equals require Webpack merge. We just installed that. Webpack merge right there. Now what I can do is set module.exports to be the function call of merge, where I pass common in, and then this object. And I need to make sure I add my closing paren down there. And what this will do is say merge whatever is in common, which is this, with what we have here in this object. Okay, and then I'm going to just duplicate this same thing. We don't need HTML Webpack plugin in this file. We're not using it. We're using it in the common file. So I'm going to go to production, delete that, and then I'm just going to copy this same line here, right here, and then add my paren at the end. All right, so all we're doing is changing mode and the output, dev versus production. Looks good, save both files. Now we need to tell Webpack which ones to use. So in package.json, when we run npm start, we're going to make config webpack.dev.js. And then when we run build, we'll set it to be webpack-config webpack.prod.js. And keep our fingers crossed. Let's see if it works. So let's start with, let's do dev first. So npm start. npm start. Moment of truth. It looks like it worked. Let's look at our index, the new index HTML. You can see that the script is just main.js. It's not main.blah, blah, blah, abcf, something like that, .js. And if we look at the script, it's main.js. It is not minified because we set mode to development. Now, instead, if I run npm run build, so not just npm build, but npm run build, that's going to call Webpack with our production file, with this config file. And let's look at our index. You can see we now have the content hash. And if we look at the right file, 179D, right there, it is minified. Okay, so this is just the beginning of setting up development versus production. I mean, we have it set up, but there's a lot more that we can do to differentiate the two. So the first thing I'm going to do is set up a dev server, a Webpack dev server, so that when I'm in development, I don't have to keep building like this. I don't have to do npm start every time I want to see something. And it's really easy to do. npm install -- save dev webpack dev server. And this is actually not something we really have to add into our config file. Instead, we're going to go back to our package.json, which is, where are you? Oh, I guess I closed it down, or I'm blind. Okay, here it is. Instead of Webpack, we're going to run Webpack dev server. And then at the end, we can optionally pass in --open. It doesn't have to be at the end, but somewhere, a flag. And what this will do is open up the window in our browser for us. So let's see if it works. When I run npm start, we should now end up with the dev server opening it. There we go. It opened up automatically for me. I'm getting all my code here. And if I go and make a change, let's say I change the color in my SASS file. Instead of teal, let's go to magenta and save. You'll see it automatically rebuilds and my browser refreshes, it updates. And you can see that happen over here. Well, it's going to be kind of annoying to point out, but you can see it rebuilt again and that certain things changed, it detected them. Essentially, you'll see a bunch of scrolling text if you change something. The other thing I want to make clear about this, if I actually remove the dist folder, so rm-rf dist, you don't have to do this, but I'm going to delete it. Now, if I run npm start, which is using the dev server, here we go. We see our code. Let's tweak it back again one more time. Let's go back to teal, save. It updates automatically. We'll close out with Control C. If I do ls, if I use ls, there is no dist folder. So it actually does everything in memory. It doesn't actually make a folder for you when you run it with Webpack dev server, which is nice. We don't have to keep, deleting these files or making these files and overwriting them. It's all in memory. But then if I want to spit it out, npm run build, this will give me my production version where I can now, open it up manually or I'm going to put it on a server somewhere and, use this as an application. So now I would need to open dist/index. And it's working, well, aside from the image, which we haven't addressed yet, but our JavaScript is here and yeah, everything looks good. All right, so that's the end of this video. I'm going to commit right now if you're following along. I'm adding a bunch of detailed notes to the commits, by the way. So if you ever get lost, you're not sure which one I'm using, there's the main commit message and then some bullet points below that explains, what we did. All right, so I'm going to commit now and then I'll be back with another video. In this video, we're going to talk about two loaders for Webpack, file loader and HTML loader, as well as a nice plugin called Clean-webpack plugin. So we're going to start with the loaders. Right now we have this image that isn't really working. Well, it's not working at all. And actually the reason it's not working right now is because my path is incorrect. Originally we had our index.html file right here on this level, and the file, the image is assets/webpack.svg. So the path was just ./assets/webpack.svg. And I copied this whole thing into my template, but now my template is inside of the source directory. So what I could do is just change it to be ./assets. As you can see, this should work. If I rebuild one more time, my index.html in the dist folder is now linking to ./assets. So this does technically work, but this is really not a good way of doing things for a couple reasons. One is that we are hard coding this path in, and it relies on assets being in a sort of a sibling folder, being in the same folder as dist. The dist folder is supposed to just contain everything we need. It's supposed to be, the build of our app. It should have everything we need contained in this folder. So the fact that our assets is on its own and we just happen to link to it correctly is not ideal. So what we're going to do is set it up so that my assets are actually copied into this folder, and we'll work on hashing them for cache busting, so they'll have new names, sort of like our bundles down here, and the links are going to be dynamic. The source in our image will be dynamic. So there's a couple things we need to do. The first thing I'm going to do is move my assets into source. So source will have an assets directory. We'll reference it in here. Webpack will then take those assets, copy them over to dist into a new folder, and then we'll link to them and it will be sort of magic. Okay, so I just moved the assets folder, and then the path now needs to change in my template. So my template is in the same folder. So it's ./assets/webpack.svg. Okay, so that works, but then we're going to have the problem when I run npm run build and I open index. It's looking for ./assets, but there is no assets folder in dist. So we're back to our same error or issue before. So we're going to do two things, two loaders to help us. And the first one is called HTML loader. And I have the docs open for it here on GitHub. What it will do is replace, well, anytime it encounters a source for an image, it will require that image. It will tell Webpack, hey, here's a file that we need to load. I need you to figure out what to do with it. And then we'll have to tell Webpack how to handle those files like we had to do with a CSS file or an SCSS file. But instead, we'll tell it how to handle JPEGs and PNGs. But we're going to start with the HTML loader. So it's pretty straightforward. npm install -- save dev HTML loader. And while that's going, in our webpack.common, because this is common across all of it, we're going to add another rule where the test will be for .html at the end of a file name. And then we're going to use HTML loader, just like that. We don't really have to configure very much. This is fine on its own. So what happens is that we're using this template.html. It's being required, essentially. Webpack is going to encounter this, and because we have this new loader we just added in that says, hey, if it ends with HTML, let me take charge of it, use HTML loader. So then that's going to come across this source, and it's going to require this image in JavaScript. And then Webpack is going to freak out because it doesn't know what to do. So I'm going to show you that right now. If I do npm run build, we're going to get an error. Here we go. So what happens is it comes across this SVG right here because it was imported, and it says, I don't know what to do. Module parse failed. Unexpected token. You may need an appropriate loader to handle this file type. And indeed we do. So we're requiring any images in our template now. They are being required, imported into JavaScript, but now Webpack doesn't know how to handle them. So this is where file loader comes in. So this will help us actually load those SVGs or PNGs or JPEGs. So we're going to begin by installing it. So npm install -- save dev file loader. And while that's going, we can add a new rule. And this one, the test, is going to be a bit different. I'm going to copy this, but instead of .html, and instead of just hard coding .svg, I'm going to give it a couple of options. So SVG or PNG or let's see, JPEG or GIF for now, or GIF, however you pronounce it. So in a regular expression, this is or, so any of these will match as long as there's a period and then one of these choices and then a $, which signifies the end of the line. So it's .svg and nothing else, .png and nothing else. And then instead of just doing use and then passing in file loader, I'm going to actually use a different syntax here, where use is an object, and we tell it the name of the loader, file loader, and then we pass in some options. And the reason I'm doing these options is that I can specify things like the name of each file. We'll begin with something simple, name.ext. So remember, HTML loader is importing this asset, and JavaScript, Webpack doesn't know what to do with it, but now we have this loader, and we're telling it, you should make a copy of this, move it over into the dist folder with this name. So whatever the file name is, the extension. But I'm also going to add in the hash just to show you that we can do that. And it's not, as far as I know, it's not content hash like it is up here. Where is that? In production. It's hash. Maybe both will work, but this is what I've seen in the docs. And then I'm going to give it a output path. And this is where our assets will go. So I could call it images just to show you that we can do something different. And now inside of our dist folder, if I close node modules down, when we run this, Webpack is going to encounter this image because the HTML loader encounters it inside of our template because we used a source. It imports it, and this loader is triggered right here where we have SVG that's matching. So then it copies it over into a new folder called images in our dist, and the name is going to be webpack.svg with a hash in the middle. Okay, let's see if it works. So we're going to run npm run build, and it looks good so far. Inside of dist, we have a new images folder. Notice the file name. It's really long. Webpack.contenthash.svg. And the best part, if everything works, our index.html now has image with the source set to that. It's no longer set to what it was before, assets/whatever.svg. It is dynamically linking to the correct image. So now if I added another image into the assets folder, whatever I added in there, if it was SVG or PNG or JPEG, and then I used it in my HTML template, I used image source equals something, it would be required, it would be loaded, copied over with a new name. There's other things we can do as well, like setting compression on our images, but I'm going to keep it simple. So we are now loading the files correctly. And if we go refresh the page, we see the image. And if we use our live server, it also should work just fine. And it does. Okay, so now moving on to the plugin I mentioned, the Clean-webpack plugin. You might not notice this yet, but if I go and make some changes to some of my code, let's say I go back to index.js and I add another console.log. It doesn't matter what it is. Console.log j, I meant to type hi, but I mistyped. If I build again, npm run build, what happens is that we end up with another bundle. And every time we build, if the code changes, we get a new JS file. And we only use one of them. Our index only links to one of them each time. So we'll quickly install a plugin called Clean-webpack plugin, which will delete the dist directory every time we build, and then we'll have a clean slate to add our code into, or for Webpack to do it. So to install the plugin, it's npm install -- save clean-webpack or clean-webpack-plugin. And while that's going, let's go back to our webpack.common, although we actually only need to use this in production. When we're using the dev server, it doesn't matter because those files are in memory. When we stop the server, they go away. In production, it's actually exporting, it's building the dist folder and making those files. So I'm going to import Clean-webpack plugin equals require, and then it's just Clean-webpack plugin. Okay. Now I can pass in plugins here, like we have over in common.js, where we're doing this HTML Webpack plugin. Can do the same thing, but this time it's new Clean-webpack plugin, just like that. So right now, every time we build, if we change our JavaScript or CSS or any of our code, we end up with a new bundle file, and that's just going to keep going until we delete them. But now with Clean-webpack, every time I run npm run build, assuming I didn't have a typo, we'll see that it is cleaned up and we only have one file. So everything that was there is either deleted and rebuilt, or if it's not being used, if it was left over from the last build, it's abandoned. It's completely removed. And again, we only need that in production. It wouldn't hurt to add it to common or to dev, but in dev, our files are using the dev server and they're just in memory temporarily. They're not actually written down. They're not saved to the system. All right. So we saw two things here: file loader with HTML loader to get our assets into a new directory and have the links work correctly. And then also we saw how to quickly add into production the Clean-webpack plugin. All right. So I'm going to commit now, and that's it for this video. Next up, let's talk about configuring Webpack to work to spit out multiple bundles. Instead of just one with everything, we might want to separate out our own app code from our vendor code. So let's say we're using the Bootstrap JavaScript and a couple, jQuery and maybe some other library that we need, but they're not going to change very much or ever in our application, but our main code will. So we can have two different bundles, and one of them will be vendor.content-hash.js. It will stay the same almost all the time unless we update that code or we upgrade which version of Bootstrap JavaScript we're using or something like that. And then we can have our main that changes more frequently. So this is actually not too difficult to do. All we do is set up a different entry point if we want. So inside of source, I'm going to make a new file called Vendor.js. And to start, I'm just going to put, alert hi from vendor. Just like that. And then I'm going to go into my Webpack common.js where we have our entry. It's set to index.js. I'm going to make it an object instead. And then each property will be the name portion of a file, main will be based off of index.js, and then vendor will be based off of /source/vendor.js. So now Webpack is going to work its magic on both of these entry points. It's going to take this first one and it will call it main, but remember in production, we have a problem in our output where we're always calling everything main. So I'm going to refactor this to be name in brackets, which will be main or vendor, .content hash, and I'll also do .bundle.js. And then in dev, I'm going to change this to be name.bundle.js. So that name is coming from here, main or vendor. We have 2 entry points. Let's see what happened now. Need to add my comma. All right, let's try it with npm start using the dev server. It opens it up. Okay, so we get hi from vendor and then everything else loads. Okay, that alert is kind of screwing things up. But if we look in our sources, we have a main.bundle and a vendor.bundle. And our vendor bundle includes our alert as well as some other Webpack stuff. And our main bundle includes all of our files and everything that we have in our app logic, the code that we're writing. So let's go back and test it now in npm run build and just make sure that the content hash is working. So our file names are named correctly. We have main.contenthash.bundle.js and vendor.bundle.js. And then instead of our index, we now have 2 script tags, as you can see. So I didn't add either of those. Both of them were added automatically. So you can see now, hopefully you can see how this becomes pretty easy. If you want to have multiple files or multiple bundles, all you do is add a separate entry point. So let's now go and add some Bootstrap JavaScript in so you can see the utility of this. So inside of my Vendor.js, I'm going to just import Bootstrap, just like that. We already installed Bootstrap up in Node modules, and we're using the CSS, but we're not using, here's a CSS by the way, we're not using the JavaScript. If I wanted to add a navbar in, which requires JavaScript, let's just use this simple one here, which will use JavaScript when you collapse or when you shrink the page down, it will collapse into the little hamburger menu. So if we don't have JavaScript, it won't work. So right now, if I just comment that out, I go to my template at the top of the body, I'll just paste in my navbar, save. And now if I run npm, let's do just a local server, npm start, we get the navbar and it does collapse, but the toggle, the drop down is not working. We're not getting that drawer because JavaScript is not running from Bootstrap. So we go back to our code in Vendor.js, I'll import Bootstrap and you can see we run into an issue. So after I saved over here and I imported Bootstrap, I didn't even have to restart the server, but it says that Bootstrap can't resolve jQuery, which it relies on, and popper.js. So 2 dependencies I'm going to install, npm install -- save dev jQuery and popper.js. On the Bootstrap docs, it makes it pretty clear that you need those in order to use Bootstrap. I just didn't include them right away because we were only using the CSS, which doesn't depend on those. So now if I run npm start, and here we go. As I collapse this down, there we go, our JavaScript is working. Lastly, let's do npm run build, and we'll see our Vendor.js that is spit out right here has all of Bootstrap JavaScript included. It also has things like jQuery in here, which it depends on. If I search for jQuery, you can see there's 71 instances of it. Here is where it's included. We also have Bootstrap, we have popper.js, so all of those dependencies are loaded, and that's what our Vendor.js file now contains. And then we have our app code, which is in main.js, and it's all being minified too. It includes the Bootstrap CSS. We will, in the next video, work on extracting CSS out into its own file. But for now, it's all happening inside of this file, main.js. Okay, so we just split up our code. We imported Bootstrap into Vendor.js. You could follow this pattern with whatever other libraries you're using. So aside from Bootstrap, if there's other JavaScript libraries that you want, you can put them in Vendor.js and they will be bundled together into their own file. And it will always be that same content hash unless those libraries change or you somehow add something new in here or change the code. This allows a browser to cache this file separately, which is less likely to change. And then your main file could change a lot more often. All right, so I'm going to commit my code with Git, and then in the next video, I'll be back to talk about minimizing HTML and CSS, extracting our CSS into a separate file. Right now, we don't actually see a file here, but it's just magically working. So next, we're going to talk about minifying CSS as well as HTML. But first, we're going to discuss extracting our CSS into its own file, or files if we prefer. So right now, everything is being loaded through JavaScript. Here is all of our Bootstrap CSS as a giant string in our main.js bundle, which then is injected into the DOM, as we've seen before, as a style tag. So this works. There's no problem with it as far as functionality. It's getting there. Our styles show up. But in production especially, it's nice to have a separate CSS file rather than waiting for JavaScript to inject the styles. And the main reason has to do with performance. If I load this page, I don't know if it's going to show up in the screencast because it's so quick. If you watch over here, we'll see there's a flash of the unstyled content every time I reload the page, or almost every time. So what's happening is that the page loads, there is no CSS at all. All that is happening is a single or two JavaScript script tags at the bottom of the page. So all of our content loads, the HTML elements, H1s, inputs, buttons. Then we get to this script. And these two scripts run, and one of them takes our CSS, and it finally injects it into the DOM. So it happens very quickly, but everything is actually loading first. So there is no style sheet up here that is going to style things first. So there is a flash of unstyled content. There it is, one more time. So in production especially, we want to avoid that. It's just not a good experience for users. We want our CSS to load, have it be up in the head, everything is styled, and then our JavaScript can load, and it might take a couple milliseconds or sometimes longer, and we won't have to wait to get our styles. Now, the reason we're not going to do it in development mode is that it takes time to spit out CSS files. It's much faster when you're just developing with the dev server. You don't want to wait each time that you save something or you change your code. You don't want to wait for it to recompile and rebundle and spit out new CSS files. So we're just going to do it in production. And the way we do it, or one way to do it, is using a plugin called Mini CSS Extract plugin. So we're going to begin by installing it. So it is npm install -- save dev mini CSS extract plugin. And while that's loading, we're going to go into our Webpack production and import or require that module. And then we can use it inside of our plugins. So we'll pass it in. We'll do new mini CSS extract plugin, just like that, and save. And if we want, we can specify a couple of options. We'll just do file name and have file name be the same sort of pattern we've been following. So name dot, and then we can have the content hash dot CSS. All right, so that's the first step, but this actually isn't enough. The next thing we need to do is make sure we're using this instead of the style loader that we're using right here. Right now we're using this all the time. It's in common, webpack.common. So every time we load SCSS, the same would apply if this was CSS. We are first running it through SASS loader and then CSS loader, which remember, this one converts SASS to CSS. This one turns CSS into JavaScript. This one is what actually injects those JavaScript strings of CSS into the DOM. We don't want this to happen in production. We're trying to avoid that. Instead, we want to use this mini extract or mini CSS extract plugin to grab those lines of CSS and put them in a new file. So I'm going to actually move this entire rule away from the common config file. I'm going to put it in dev because in dev we do want it. And I need to grab module rules. I need to follow the same syntax that we had. I copied the wrong portion. Okay. So everything looks the same, module, rules, and then in production, we need to do the same thing. So module, rules, but this time, instead of style loader, we're going to change this to be mini CSS extract plugin dot loader. So it comes with a loader that we can use as part of the plugin. And this, instead of inject styles into the DOM, this is going to move or extract CSS into files. So remember, they load in, or they run in reverse order. This happens, then this happens, and then finally it should create new files for us, including the CSS that was loaded by CSS loader that was originally converted from SASS to CSS by SASS loader. All right, let's see what happens now. We will do npm run build. Fingers crossed, no errors. You never know. And you can see it takes a little while, but it should spit out a CSS file. And indeed it does. So we have this CSS file now that is separate. And if we look at our index.html that it gives us, it now includes a link tag up at the top. So we're no longer waiting for the page to load, for the JavaScript to load, to then inject our styles into the head. It's all happening at the beginning. It's compiled, it's built this way from the get-go. So that plugin is extracting all of our code, all of our CSS into one CSS file. You can configure it to do it in multiple, but for now, one is fine. This is all of our CSS, so Bootstrap is pretty much all of it. We override those colors using SASS, but if we had other styles as well, they would be in here, assuming that we were writing them in this file. And now if we refresh the page, let's make sure it still works. Notice we don't get that flash of content anymore. I'm doing the same thing, but we're not seeing the unstyled content. Our link tag is included in the correct spot up in the header. And I guess I should call attention, I use the content hash again, just to help with caching and to prevent caching when we don't want it to happen. If we change the file, this hash will change. All right, so that should be review from earlier videos. So notice that this is not minified. This is quite large. So one thing we might want to do is minify this CSS. And it's not very difficult to do. There's a plugin to help us, and it happens to have a very long name, in my opinion. Optimize CSS Assets Webpack plugin. It's one of the larger package names. Large package, oh boy. One of the larger package names that I've come across. So Optimize CSS Assets Webpack plugin is going to help us minify our CSS. So the first thing we're going to do is install it. So we'll do that now. npm install -- save dev optimize CSS assets webpack plugin. While that's going, we're only going to minimize our CSS in production. We don't need to do that in development. It's a lot easier if we only do it in production. It takes time, but it's also frustrating if you're trying to debug something in CSS when it's super minimized. It's not a huge issue. You can do it in development if you want, but I'm just going to do it in production. So we first need to import it. Here, I'm just going to use const to match everything else that I've been doing. And where we actually use this is not as a plugin on its own. We add a new property here called optimization that we haven't seen before. And then within that, we specify minimizer. And this is an array, multiple minimizers, because sometimes we're minifying JavaScript, we're minifying CSS, like we are in our case. And I'm going to pass in new optimize CSS assets plugin, just like this, and then add my comma. Okay, before I run this to show you what happens, let's take a look at two things. I'm going to close down a lot of stuff. We have a lot going on. So inside of our build folder, we have our CSS, which is not minimized. It's a very long file. Then inside of our JavaScript files, we have minimized code. So I'm showing this to you for a reason. This is all minimized or minified. Now, if I run npm run build, where we're telling it to use optimize CSS assets plugin to minify our CSS, let's see what happens. Okay, so that finished up, and let's look at our CSS now. It's minified, so that part's working, but something weird happened. If we look at our JavaScript, it's no longer minified. Why is that happening? So it's kind of annoying that this happens, but when you set mode to production, by default, optimization minimizer is set to use a JavaScript minifier, but then we're overriding it right here by telling it to use this optimize CSS assets plugin. It basically ignores what was there before, which was minifying the JavaScript, a Cursor.js plugin that we're going to reintroduce in just a moment. So we have to manually add it back in. It was there, but by adding in this plugin, we completely override what was there originally inside of minimizer. So now we don't get JavaScript being minified, only CSS. And another thing I'll show you, if we look at the message we get, it says, warning, an asset size limit. The following assets exceed the recommended size limit, 244 kilobytes. First of all, a lot of people think that this is a pretty sensitive or a low threshold for this warning. 244 is not really a huge file, but you can see our Vendor.js, vendor bundle.js, is quite large now. And we weren't getting this before because it was being minified. It's not anymore. So if we look at the file, it's quite long. It's all of Bootstrap and jQuery and Popper.js. So now we're going to add in the plugin that was already being used. We don't actually have to install it, but we do need to require it. And it's called Cursor Webpack plugin. Again, I haven't installed this myself. It's already inside of Node modules. If you scroll down, look for Cursor, you'll see, come on, where are you? Right there, Cursor Webpack plugin. I promise you, I didn't install it myself. It's not in my package.json, but it's there because Webpack was using it already. You can see it's not in here. Okay, so we're going to require it and then pass it in as a minimizer, new Cursor plugin. So Cursor is the default minimizer for JavaScript in Webpack. As I already showed you, it was being used before, but we overrode it and ignored it. So we're adding it back in. Webpack used to use Uglifier by default, I believe. Now it's Cursor, but they do pretty much the same exact thing. They minify your JavaScript. So let's see what happens now. Let's try it. npm run build. Again, I'm only minifying in production for my JavaScript. And does it work? You can see how long this takes, by the way. So we don't get that warning anymore. That's it. It's not saying that our file is too large. Vendor is now 167 kilobytes instead of, 400 something? Yeah, 484. So a significant reduction in size. And if we look at Vendor, it's minified. If we look at our main file, it's minified. If we look at our CSS, it's minified. There's only one thing that isn't, index.html. Now it's very short, but we can optionally minify our HTML in production. We don't have to use any additional plugins. We already have this HTML Webpack plugin right here. I can pass in other options. I can specify minify. This is part of the plugin documentation where I found this. And inside of minify, I can do things like remove comments and set that to be true or false. But I'm not going to do it here inside of webpack.common because I don't want to minify my HTML in development. So once again, I'm going to pull this out and move it to production. So inside of our common.js Webpack config, we don't have any plugins. They don't share anything, at least they don't share it in the exact same way. So now inside of dev, I'm going to add in this plugin again. So plugins and paste that in, add my comma, and I need to make sure I am requiring it at the top of Webpack dev. And then in Webpack production, I'm going to require it as well, but I'm going to alter some options. I'm going to pass in some minify options. So let's do that now, right here, paste it in. And after template, I'm going to say minify. And the three I'm going to go with are remove attribute quotes, collapse whitespace, remove any extra whitespace, and remove comments. Set that to be true. So let's do something in our HTML where we'll actually be able to detect this. We'll tell if it's working. So let's go to our template file and add some comments in here, like how about above the nav bar, we'll say bootstrap nav bar. And then let's add in some white space. I'll just do a single line. And we'll just leave it like this for now. We'll look for that top comment here, bootstrap navbar, and see if it makes it in to our end result when we are in production. So let's now run npm run build and twiddle our thumbs for a moment. Okay, let's look at index.html. All right, definitely minified. You can see the attribute quotes have been removed. So type equals text. There's no quotes, for example. We have no white space, or most of the white space has been removed. And then also my comment is gone. At least I can't find it. If I look for it, I'm pretty sure we'd see it pretty easily because it would stand out with a different color. So it's not in here. And let's just check that it does work. So I refresh the page. Okay, it's loading. We're getting all the code that we expect. JavaScript's working. It's minified. We're overriding Bootstrap. We're using SASS to change those colors. We have separate CSS files or a single file. Where are you? Right here. It's minified. We have our minified Vendor.js and our main.js, and then our index.html minified as well. So everything has been crunched down. Oh, we have our images too. Forgot about that. And then inside of elements, we still can see everything as normal, right? By minifying it, we're not like corrupting it. We're just shrinking it down and collapsing it into as little space as possible. Now let's just verify it still works in development. So npm start. Notice how much faster that loaded for me. That took maybe a second or two to build originally, and then rebuild should actually be faster. And if we look at the code, index is not minified. We can see my comment is here. All the attributes have quotes. Our code, our JavaScript is not minified, and there is no CSS. Remember, well, it's in the files, but there's no CSS file on its own. And remember, the reason we do that is that it takes a while to build those files. And in development, if I change something, I don't want to wait. And that's it for now. So I'm going to commit. We have a whole bunch of things going on in Webpack, and we've honestly only scratched the surface in some ways because there's a lot of other things to talk about. I mean, if we look at that list I showed you early on of the different plugins available, of the different loaders, Webpack can do a ton of stuff. But as you've seen, it's really, how should I put this, intimidating. It can be overwhelming when you're starting out. And it's something that you only really do once every project. Maybe you go and update something, but often, you're not writing code in this file in your Webpack config all that often, especially if you work at a company on one large production app. The config file doesn't change all that much. So a lot of people don't have much experience with it. And it takes some time and some practice to get used to it, but there's just nice little patterns you follow. You just remember rules, test, use. There's certain loaders that you use frequently, like style loader and Cursor.js for minification. There's these different patterns. But at the end of the day, all that we're doing is taking a bunch of different types of files. In our case, an SVG file, an HTML file, JavaScript files, SCSS, and we combine them in some ways, not all into one file, but we combine JavaScript into different files. All of our different JS files, we haven't touched these in a while, but 5 different files plus the Bootstrap.js plus jQuery plus Popper.js, and we spit them out into bundles. They're minified. They have hashes in their name that pertain to the content inside of them. So those hashes will only change if the content changes, which helps with caching and preventing caching when we don't want it. Then we have our CSS being pulled out in production. We have our index.html being built for us with all of the links included dynamically. So we don't have to write any of these script tags, right? This is all done for us. And then we set things up in development mode to be a little simpler. We have our dev server that is going to update and rebuild anytime we change something, just serving it on localhost. We aren't minifying. We aren't using the content hashes. Our CSS is not being extracted. Our HTML is not being minified, but we're still joining together all these different files and making sure everything works for us. Okay, so I'm going to leave it off here. I know that was a lot. I'm going to commit. This will be the last commit for now. Please let me know if you have any feedback. I'd love to hear what you have to think. Any suggestions or things you liked. Take a look at the code, of course. Look through my commits. And I think that's it. All right, talk to you later. I'll be on YouTube later. If you enjoyed this video, my cat and I really appreciate it. If you share it with anyone you think would get something out of it, leave a comment, subscribe please, turn on notifications. Oh, so annoying asking you to do that.